So this is free response question number 6, part B from the Release 2012 exam. The question says, write but do not evaluate an integral expression that gives the total distance traveled by the particle from time t equals 0 to time t equals 6. This is a calculator inactive question, so maybe they don't want us to evaluate it because maybe it would be difficult to evaluate, but they want us to write it but not evaluate it. And so we're making an integral expression, and the key word here is total distance. Total distance should tell us that we need to think about where this particle is moving to the left and to the right. In fact, if they had said find the displacement, then we could just do the integral of the velocity. But since they said total distance, we need to think a little bit about what that means. And it says from t equals 0 to t equals 6. So we want to find the total distance traveled from t equals 0 to t equals 6. We're going to set up an integral, but we don't have to evaluate it. So because it's total distance, we need to think about when is this particle moving to the left and when is it moving to the right. We know that total distance from between two certain times will be the integral. Total distance is the integral from a to b, which in this case is 0 to 6, of the absolute value of the velocity. The integral of velocity without an absolute value is displacement, but total distance requires an absolute value. So when I have this absolute value, so I can say this much. I can already say that this is the integral from 0 to 6 of the absolute value of my velocity function, which is given in our part at the beginning in the directions as cosine of pi over 6t. That's what our v of t is. So it's the absolute value of cosine of pi over 6t dt. So now I'm not supposed to evaluate this integral, and conceivably I could get away with just writing this because I don't have to evaluate it. If this were a calculator active problem, I could put that absolute value into my calculator and evaluate with the absolute value. But for a total distance problem without a calculator, I can't just there's no antiderivative for absolute values, so I can't just get an antiderivative and do that integral. I need to consider where is the particle moving to the left and where is it moving to the right. Well, on the previous problem, we determined that the particle moves to the left on 3, 9. So that means it's moving to the right from 0 to 3 and to the left from 3 to 6. So we're going to be moving right, and then we're going to be moving left, and we'll split this integral out into the two parts. So when we're moving right on 0 to 3. So this will be the integral from 0 to 3, and I can drop the absolute value and say cosine of pi over 6t dt. But then when I'm moving to the left, see what's really going on here is I have a sinusoidal function that starts out positive and then goes negative. And this is 6, and of course our 9 is over here and our 3 is here. So what's really going on here is we're moving to the right and then we're moving to the left. So we need to add this integral and subtract this one. So then we're going to say minus the integral from 3 to 6 of cosine of pi over 6 t dt. And that would not be a terribly difficult integral to evaluate. We could use a u substitution and do that integral, but they haven't asked us to. They asked us to write the integral, but do not evaluate it. So there you go. I wrote it, I didn't evaluate it, and that's our integral that gives the total distance traveled from t equals 0 to t equals 6.